what other things yang contribute towards your goal tu kan. So your variable tu can be, kalau dalam ni you nak projek apa you nak projek dia punya profit ke apa?
Dividend dia.
Dividend. Dividend apa yang actually contribute towards dividend tu kan. Those are the independent variable. Yang mana yang boleh affect dividend. Kan you mesti ada nombor-nombor yang you dah ni kan. So dari situ you tengok ada berapa variable you have. Kalau satu, it's just a simple linear regression. Simple linear regression is very simple. It's boleh lah buat, ada orang pakai. Dia macam satu variable, dia macam y ikut mx plus c equation kan. Sebab dia straight line kan. Lepas tu, kalau you ada banyak benda yang contribute towards your dividend tu, yang either dia nak bagi turun naik, you ada macam-macam kan. That one is you punya yang berapa faktor dia kan. So that one is multiple linear regression. But multiple linear regression, you have to be very careful juga. You boleh buat, dia ada model dia. You boleh buat, you run, sebab saya statistician juga kan. Degree dia statistik, master saya buat. So bila you run data you, statistical data, dia akan bagi ANOVA table. Yang you heard ANOVA table kan? ANOVA table kat situ dia ada bacaan dia. Banyak student tak tahu apa benda pun dalam tu. But actually there are so many things in ANOVA table that you can use. Tapi yang tu kena ada khusus lah. Kalau you all dah pakai yang tu, I can just give a very maybe workshop sekejap kan, on how to read those data and what does it mean kan. Because dalam statistik you ada hypothesis. Hypothesis tu you nak test for ANOVA tu, kalau dia ada F value, dia ada P value, kita nak tengok significant tak significant. Your problem tu kita nak tengok significant tak significant lah, or mostly kan.
Verification lah, your fit lah, betul kan?
Your variable tu, sometimes you dah dapat model cantik, tapi that does not mean the a good model. Because once you have that, you have to test what in between variable tu, dia ada correlation tak?
Between variable?
Between variable kan, dia ada correlation tak? Kalau dia ada correlation, memang dia akan affect you punya output. Itu another cost tu, kalau you buat tapi multi-collinearity. Multi-collinearity, you kena check for multi-collinearity. And tu, bila ada multi-collinearity, you kena adjust the variance semua tu. Dia ada VIF method, dia panggil VIF method. Dia have to apply VIF method, baru you akan dapat the real cantik ni model.
Okay, you're talking about dependency lah between the variable kan. So actually variable tu bukan independent, totally independent. They should be clustered kan. Is there a way to cluster variables lah?
To cluster the between variable tu?
Because they are not totally independent.
Macam covariate tu?
Macam tu?
Covariate tu, that is the technique ni for covariate. Sebab tu I kata kalau nak ni, I kena tengok apa benda you ada kan.
What are you trying to apply it for? Image processing ke ataupun natural language?
Fokus.
Fokus like fokus pre-swap ke macam tu semua.
My student buat project on my just finished my student is very good because dia dapat first hand training from me. Dia buat about housing prices around Yemen, KL, so dia buat how big the house for yang ni, what makes the house expensive. Dia boleh fokus lah. Tapi within kita punya Khairani ni, dia ada area yang memang akan mahal je. Kalau satu memang mahal kan, walaupun dia same build up, but in Selangor maybe cheaper. Macam tu lah, macam nilai kan. So dia akan study lah between tu. Dia buat lah, dia buat.
Dia boleh pakai untuk matchmaking lah.
Dia buat cantik dia punya projek semua. Memang dia pening kepala, dia main data saya macam ni memang. The thing is I can give advice when I see mereka dah buat. Mereka dah buat, dia pokok main, tengok, then I know yang tak betul. So he keep on, dia kata susahnya buat projek ni. I kata the best, I kata you trust me when you work out, when you work ni orang akan hire you lah kata. Dia kata memang saya buat. Budak tu memang sediakan Kingsley punya suka ada so dia boleh buat lah. Tu yang dia nak buat. LI tu latihan industri tu I nak hantar dekat sekian apa ni ya. Dia tak mau, I kata
Tak ada boleh kan?
tapi budak tu dah dapat dah, dia balik Penang. Dia nak ada Penang, ada budak Penang.
Anak Omi ya? Bagi kenal kan?
Dia lelaki lah perempuan.
Okey, tak apa, aku baru duduk. Okey.
Budak ni memang ini Iron Man punya, April punya semua menang, medalist. Body memang cantik. Budak ni mesti tahan.
Okay, tapi pricing, if you're looking at time series pricing betul tu. Okay, one of the time, you're looking at ni kalau stop booking orang kata, you are looking at fundamentals or you looking at the technical. Dia ada dua tau. Fundamental tu macam dia nak tengok kata stock price. Stock price tu bergantung pada faktor-faktor yang affect industry factor lah kan, industry factor yang this what you're doing, trying to do using linear regression. You're looking at industry punya whatever yang factor-factor yang akan menyebabkan stock price tu naik turun lah. This is fundamental analysis. There's another one that I practice. I don't really look at fundamental, tapi ada orang tengok fundamental. I put a very low weightage on fundamental lah. I look at time series. I look at dia panggil price action. Price action tu is when you read the graph. I'm a trader. I started a top 10 stockbroking firm. So I look at the graph. I know how to read lah the graph tu. Bila dia nak turun, bila dia nak naik, bila dia nak recover apa tu semua. You know how to read the line lah. Yang tu you do using something called recurrent neural network tau. Recurrent neural network ni is quite expensive pasal dia bukan single pass macam tu punya neural network.
Tak boleh tanya cek je.
Boleh. Itu semua boleh tanya. Semua dah pandai. Okay. So lepas tu kan dia every node tu ada processing juga. Dia bukan simply shoot out dia punya apa tu? Trigger dia kan? Bukan. Dia dalam setiap satu tu dia ada processing juga. So extensive lah dia punya processing tu. Tapi RNN ni is quite effective disebabkan apa tau? Dia ada something called long short term memory, LSTM. So long short term memory ni dia kadang-kadang masa kita tengok signal tu, kita tengok graf tu, some signal are not important, some signal are important. Okay, you ada feel dia tahu lah, some signal important, some signal not important. Kadang-kadang signal tu dekat dengan event. Kata you are now here. That signal ni, kalau you pakai traditional method, yang dekat-dekat ni akan have more importance lah. Makin jauh dia makin kurang lah important dia. But that doesn't apply to prices. You're talking about oil prices atau apa kan, oil prices. Kadang-kadang there are some things yang happen in the behind that's more important than the thing that's happen in front. So LSTM is very good at that. Okay. The only thing is that LSTM involves a lot of you have to redistribute balik your error ke apa ke, your weightage apa semua tu dia banyak distribute balik weightage. Okay. Bila you banyak distribute balik weightage, katakan for example you redistribute 0.1. Bila you redistribute 0.1 multiply 0.1, sini dah 0.1 to the power of 2, sini 0.1 to the power of 3, 0.1 to the power of 4. Dia pergi ke belakang tu, dia panggil disappearing gradient. Dia lama-lama dia tak ada impact lah dia punya weightage sebab dia terlampau multiply banyak kali sangat. 0.1, 0.101, 0.001. But it's important, tapi dia dah hilang. Lepas tu kadang-kadang kalau weightage tu besar sangat, 10 ada 10 dah jadi 100, 1000, 10,000. Kena 5-6 kali dia dah meletup. Dia dah terlampau tinggi sangat. Dia overwhelm all other weightage. Tu nama dia exploding gradient lah. Tadi disappearing. So ada pula cara dia untuk mitigate lah the impact of this disappearing apa semua ni. You buat macam sampai satu limit dia flatline ke something like that lah. Tapi tak berapa efektif jugalah benda tu. pumpang. Okay, anyway that is still being used untuk high frequency trading. High frequency trading ni now, for example in Japan, 90% of the trades are being done by computers. Kalau dekat New York Stock Exchange for example, 55% dah done by computer. Buka-buka aja bursa tu terus
persen tu dia punya
rush. Dalam masa 10 saat they can do like $40 million transaction. Terus dah banyak ya. So in those brokerage is a game of programmers versus programmers. Pasal high frequency versus high frequency tu. Program versus program. So masing-masing nak baca signal cepat. Sebelum kawan ni, there's a lot of companies open their brokerage in the same building as New York Stock Exchange. Dia tak payah pergi keluar. Pasal dia nak dapat signal cepat. Apart from cepat, nak accurate dan nak proses cepat juga lah. So they use this RNN lah basically untuk buat benda tu. That's why Elon Musk pandai. Elon Musk buat Starlink tu, tapi kita nak buka katakan kedai, nak buka shopping mall, kita kena cari anchor tenant. Anchor tenant tu yang bagi hidup tu shopping mall. So Elon Musk cari anchor tenant dia stockbrokers. Pasal bila kita hantar signal melalui space, kalau katakan across the Atlantic, we can be like 7 seconds faster than by cable. So cable tak efficient sangat. Cable banyak error apa semua. So ada error hantar balik apa semua dah. So cable. So by space ni vacuum. So dia punya Starlink tu banyak satellite, dia menghantar satellite turun balik lah. Dia 7 second faster, which is very significant in terms of you depan kawan tu walaupun 1 saat dia 0.1 saat, as long as you are in front of the guy, basically. So this thing that game lah. Okay, so RNN ni dia guna untuk sequence. Yes, price sequence kan. Oil price tu tengok sequence lah basically time. People are also using it for languages at one point of time. Pasal language ni pun ada sequence juga. Saya hantar anak pergi sekolah, it's a sequence. Sekolah hantar anak pergi saya, dah sequence dah. The sequence alone dah ada impact. I live to eat, I eat to live. The same word dah ada impact yang lain kan. So dan word ni pun dia ada importance kat sini. Bukan importance tu bukan immediately sebelum ni tau. Importance tu kadang-kadang kat tengah, kadang-kadang importance tu kat depan. So using it, tapi it's too expensive and we have this problem of gradient tu semua tu. Google came up with something else. They call it transformer model. This is the one that is being used in GPT, transformer model. But I suspect the transformer model is not purely transformer model tau. Dia ada benda lain. Pasal kalau dia pandai proses language saja, dia ada pandai cakap. Tapi ChatGPT ni dia pandai factual. Dia bukan saja pandai cakap, dia pandai facts pun dia pandai. In fact, kalau kita minta ChatGPT ni tabulate katakan obesity, male and female among countries. So katakan column 1 countries, column 2 gender, column 3 katakan number between what weight to what weight, or weight to what weight. So dia boleh buat column lah. Dia tak pakai language tu. Dia keluar tu output dia is in terms of tabular. And dia boleh buat. But the fact is dia pandai proses language. Dia boleh infer from the language. Bukan saja dia keluar balik data, dia boleh infer from the data lah. Kita boleh tanya dia lagi, kenapa kawan ni Japan banyak gemuk perempuan, Singapore banyak gemuk lelaki, dia kan asosiasi. Dia boleh infer, dia fikir balik, dia cakap kemungkinan ni semua. So there must be something else behind it apart from transformer being able to come up with good language, understand language and come up with language. So back to your oil punya tadi tu, you could be looking at RNN lah. Transformer tu is more for language lah. But transformer is very new. And why transformer can process data and infer from data when it's only designed for languages is one aspect that we got to look into lah. It's like I tried to use Midjourney. Midjourney ni orang pakai untuk melukis lah. So Rita tu buat my art on in a gallery, and then adalah jual sikit-sikit. So gambar hantu. Banyak gambar hantu lah. We are trying to do ni lah. We are trying to do an art show dekat Dracula Museum. Transylvania. AI nya art.
Ayah mathematician ada kat surah dah lah.
Dracula is a mathematician. I kelentong. Okay, lepas tu you might be looking at RNN untuk buat, if you want to look at the technical analysis, the graphnya tu. To me, as a trader, I quite often ignore lah fundamental, because the fundamental will be reflected in the graph. Macam mana katakan ada some industry factor pun, it will be reflected in the graph. So I just look at the graph saja. Graph tu ada orang main, ada orang bodoh, orang pandai pun ada, orang tamak, orang ni pun ada, human behavior pun ada. This factor pun ada juga sekali dalam tu, industrial factor. So by looking at the graph, I summarize everything. Tapi yang kita baca juga news semua tu, just to know lah sekarang ni apa cerita, emas harga berapa, USD macam mana, euro macam mana. Ada baca sikit, tapi tak baca banyak. Most of the time look at the graph. So you might want to look at RNN if you want to bring prices, because that's what people do anyway.
Bukan you time series ke? You ada supervise someone time series. Mozi, kamu Mozi buat time series?
It's called supra supervision, not supervise. Supra supervision ni maknanya bukan supervisor tapi tolong.
Tolong for free. Don't get anything.
Tahu bukan lagi time series, apa-apa pandai je.
Construction pun yang buat rumah pun main telegram.
The other way is Fourier lah. Yang time series yang lama macam ni, macam zaman dulu dia pun banyak pakai Fourier lah. Break down the cycle.
Fourier analysis. Fourier pure maths.
It's not pure maths.
Pure maths. Fourier analysis. Fourier in calculus.
Calculus.
Yes, calculus. Tak ada dalam you pure maths lah.
I'm unsure.
But in AI we use a lot of calculus. The best dia panggil activation function lah.
You know, my student tanya, why do we learn calculus? Aku masuk muda.
Tak nampak lagi tu.
Dah cakap dah nak predict nombor ekor, habis dah.
Dia kata, why do you come to university? Why are you in this program? And then you ask me why you want to be a tutor? Dia masuk urusan pun hang kena belajar pula kan? Tak nak buat banyak langsung. But in a data science program, boleh tanya soalan.
Jawab senang je. Because it's fun.
You don't see it's fun. It teach you how to logic, think logically juga. All the theorem, all the things kan. It makes your stupid brain to work on, prove some theorem. Kan, I mengajak calculus tuan ni. People dump everything. All sort of maths saya kena buat. Budak apa sih? Tahu dah.
Tak nampak.
Sakit kepala mengajak dia. Kadang-kadang dia cakap apa, kita gelak je kan. Dia cakap kau ni masuk universiti buat apa? Kau masuk program ni buat apa? Kau pergi baca lah banyak. Orang ada phone ni. You boleh Google on the spot. Why you need calculus?
Kita tu beli buku RM70, RM80.
Buat dah ni dah kan. Kita
dah ni
pun
free
ada.
lah.
Semua ada. Everything is in there. Pandai ChatGPT semua tahu. Tapi nak meniru lah yang tu. Nak buat report kan. Tanya ChatGPT buat.
Dan ni exam nak kena interview lah ni. Tak boleh buat pakai kertas lah. Mungkin interview. Do you know where you use calculus in artificial neural network?
YMS. YMS klasik. Punya central.
Equation.
Bukan calculus. Yang tu linear.
Linear equation.
Where do you use calculus?
Bukan.
Differentiation ada yang dalam Z.
Differentiation, integration, kat mana you pakai?
Ada pakai sebelum time series tu kena buat statistical test untuk non-stationarity. Kalau tak stationary kita kena differencekan dia data.
No. Fundamentally, your activation function. Most activation function is not linear. Okay? You ada satu node dalam neural network tu. dia terima all the inputs from all the other nodes. Can you imagine that? Your neural network kan banyak node kan? So kalau dense punya network, you have all the nodes connected to one node lah. Then one node connected to all the nodes in the next series lah. So you receive the inputs, you have to produce an output. How do you convert the inputs to the output? You use an activation function. Most of the time, orang pakai sigmoid curve, S-curve. S-curve for the function. Pasal apa S-curve? Pasal S-curve is natural. You tengok macam consumer behavior. Consumer behavior katakan keluar something new, macam AI. Mula-mula yang nerd ni dia pakai. So dia tengah naik, dia naik sikit je. Tiba-tiba something happen, everybody start to jump to the bandwagon. Dah jadi ChatGPT semua dah melompat dah. Dia laju naik. Lepas tu sampai satu point dia dah saturated. Orang pun dah boring ke, everybody dah pakai ke apa. Dia tak grow je dah. Everybody dah pakai tak grow. Lepas tu nak bagi dia grow balik, you need something new pula lagi. Dan selalu produk tu dia akan keluar lah. Colgate jenis lama. Lepas tu Colgate orang dah boring Colgate jenis lama, dia buat Colgate jenis baru pula. Naik satu curve, naik satu curve. So it's an S-curve. S-curve reflects a lot of natural phenomena. So S-curve ni dia punya travelling dia. Mula-mula pelan, lepas tu laju, lepas tu pelan. Kalau you tengok dia punya velocity dia macam swing of pendulum. Mula-mula dia pelan, lepas tu dia laju. Ni speed ni. Pelan, laju. Pelan balik tadi you tengok dia punya travel, distance dia. Ni you tengok dia punya velocity lah. Velocity dia mula-mula pelan, lepas tu laju, lepas tu pelan kan. Betul tak kan? Macam tu kan. Lepas tu naik speed pelan, dia turun balik, laju balik, pelan balik kan tu. So ni semua is curve lah. So curve ni apa semua, you want to know benda tu curve tu is what you is how you transform the input to the output. Maksudnya from the curve is a graph. Kalau katakan input tu kat sini, input tu X, dia keluar kat Y lah. Y tu is your output. Betul tak kan? So to convert the X to the Y, you map to the curve tu. So kalau kata X tu linear aja, tak semestinya Y tu linear. Pasal dia lalu curve. That's where you use calculus. And then bila dah sampai kat ujung sana, so ada weightage. Semua node ni ada weightage. Okay? Semua node ada weightage kan dalam artificial neural network kan. Sampai ke ujung sana, dia dapat result dia. Result tu you akan compare dengan actual masa training. Bila compare dengan actual, you get dia punya loss function. Dia punya berapa silap dia. Silap tu you akan bagi balik tu pada node yang tengah-tengah ni semua ni mengikut dia punya weightage. Mengikut dia punya tanggungjawab dia menghasilkan kesilapan. Dia bukan bagi even dia ni mangkuk ni yang banyak bersilap. Dia ni basan lah yang kita silap ni. Bagi dia banyak sikit. Yang silap tak banyak bersilap tu tak payah bagi banyak sangat dia. So dia will readjust dia punya weightage. Back propagation tu. Kat situ dah dia belajar. Lepas tu hantar balik ke depan, lepas tu hantar balik ke belakang, hantar balik ke depan, belakang. So bila hantar balik tu, dia terbalik lah pula dia punya calculus function dia. Pasal sekarang ni kita datang Y nak cari X pula. Tadi X nak cari Y, sekarang Y nak cari X. So S tu, this is very fundamental in neural network that you use calculus. Okay, kalau you tak belajar all these kind of mathematical reasoning, you akan cuba macam-macam. Main tembak try tengok jadi tak? Main tembak jadi tak? Okay, for example layer ni you try tembak activation function, katakan sigmoid curve. Yang ni pula tangent punya activation function. Yang ni pula try linear, ni pula try. Main try tak jadi lah. Kalau you tahu the nature of your problem, apa your domain yang you nak try to read tu, and you know the mathematics inside there, you can make a better guess macam mana nak design your artificial neural network. Faham tak? So that's where tapi you bila dah boleh pandai corak you punya calculus dah bukan kira kata dah jaga dah. Kalau macam ni jadi baik aku pakai ni. Kalau ini macam ni yang baik aku pakai macam ni. For example lah, kata sigmoid curve dia tak ada negatif. Pasal dia zero, dia punya y dia tu is 0 dengan 1 je. So you look for probability 0 and 1 saja. Tapi kalau you pakai up 10, dia turun sampai ke negatif 1 sampai ke 1. So kat mana you nak pakai yang curve yang negative 1 sampai ke 1 ni? Kat mana you nak pakai 0 sampai 1? So you get a feel for it lah, based on the situation that you face. Sebab
Tapi macam kita nak ada tu berapa notes kita nak pakai, berapa depth dia.
ya, benda tu tengok domain lah. Tengok domain, lepas tu nanti kita kena tengok unit processing pula. Tengok processing tu semua.
Mana Datuk ni? Meeting habis ke dah ni?
Kita makan ni tak best.
Kawan saya tu lah, dia neuro apa tu kan? Neuroscientist. Kalau lah dia setuju satu lagi, kita boleh sembang dengan dia. Online lah, dia kat London. Boleh compare pula apa beza antara neural network dengan real human neural network. Contohnya, kita punya neural network ni, dia layer by layer. Dia tak tembak sekali tau. Dia kena buat layer by layer. Kenapa dia kena buat layer by layer? Pasal dia kena kumpul, kan dense punya network tu, semua pergi ke semua. Kawan ni pun pergi ke semua. Yang kawan ni kena tunggu sampai dia dapat semua tu. Yang kawan ni proses, baru dia dapat semua input. Baru dia boleh proceed. Jadi dia kena buat layer by layer lah. Kawan ni kena habis dulu, baru kawan ni boleh buat. Kalau dia habis, baru kita buat. Human neurons may not be like that. Human neurons may be fire terus. Dia tak ada layer by layer.
Seperti yang dia ni.
And then dia mungkin tak susun pun layer by layer. This guy could be in the first layer in one pathway. He could be in the third layer in a different pathway. So it's more complex. Nampak tak kan? So tu boleh tanya
Tak ada
dia.
orang buat macam tu ni. Tak ada research buat dia. Macam graph
model.
network itu.
At the moment lah, looking from a business perspective, what we have now is that complexity yang kita ada sekarang ni. Dia macam voodoo art lah sebenarnya network ni. Dia try menjadi. Pakai je lah. Kan? Kita pun try je. Konon lah macam otak manusia. Tiba-tiba jadi. Oh, okey, kita boleh pakai lah. Okay, so that particular complexity yang dense network ni apa semua ni, tambah kalau kita buat jadi RNN atau tu lagi kompleks lah, pasal dalam tu sendiri ada proses. Dah cukup. Apa nak menyusahkan lagi? Tapi kalau katakan kita nak buat sampai susah macam human brain ni, mungkin komputer kita tak cukup lah. Mungkin kita pakai quantum komputer ke, mungkin tak tahu lah. Yang pun tak try benda tu. Sekarang quantum komputer try kat orang lain tu, which is also very important. So I think the answer to your question is, benda tu that complexity dia lagi kompleks, lagi mahal, lagi susah mesti nak buat apa semua. Kita dah boleh pakai takat ni pun dah bagus lah. Cukup kita pakai je. Tak payahlah nak buat sampai tu kompleks.
Dia orang nak buat semua tipe output dia.
Dia tu je. Kita nak, from business point of view, you nak dapat RM1. Dapat RM1, you nak menabur si 10 sen ke nak menabur 50 sen. 50 sen dapat RM1, 10 sen pun dapat RM1. Baik tak 10 sen je. Kau pun dah tak ada 50 sen. Macam tu. Dapat RM1 kan? Katalah you tak 50 sen, dapat RM1 20 sen. You tak 10 sen, dapat RM1. You tak 50 sen, dapat RM1 20 sen. Tak payahlah 20 sen tu. Tak 10 sen je, dapat RM1.
What's the probability?
Pareto principle.
Kalau AI sekarang ni dia boleh produce apa tak spesifik kan. So macam kita buat tu dia akan keluar produce buat output yang kita nak. So mungkin di future nanti dia akan ada smart design. Sekarang kita ada
Tak
banyak
itu yang kita ada. Yang dia orang panggil large language model ni, ChatGPT, yang OpenAI kan, lepas tu Lambda, yang ni tu. Yang tu is general, it's not specific to any particular customer.
General ni maksud macam let's say something AI ni dia capable of doing let's say NLP. At the same time dia boleh output lain macam image processing. At the same time dia boleh output yang
Tak, itu selalu orang letak orang letak a few AI together lah. Orang letak image processing together dengan macam kata Midjourney. Midjourney kita bagi text input. Tu text processing lah. Tapi dia keluar dia gambar. Gambar tu macam dia pandai nak proses, dia dah belajar image processing kan, dia belajar dari image tu semua kan. Kita cakap kat dia, lukis gambar Prof Zaharin ni tapi seolah-olah dah Vinci lukis. Jadi tu macam lain. Lukis gambar Prof Zaharin tapi seolah-olah Rembrandt yang lukis. Ataupun siapa yang lain yang lukis semua ni. So dia akan keluar macam tu semua. So dia combine a few AI lah. And selalunya itu pun yang kita buat, kita combine a few AI. Dia meeting gitu. Makan ni? Saya dah makan dia.
Okay, nah, kita makan ni. Pandai dukuk ini soal ya.
Aznie is on the way. ETA 206. Aznie is a scientist from Ministry of Planet. She's doing work on water, energy and food. So she is coming at 206. Start lagi sampai tu.
Ni NLP lah.
Okey, Dato' Sabirin tak boleh main. Dia kata dia ada meeting, lepas tu ada meeting lagi.
NLP korang ada macam nak buat document processing kan. So my vision is, our vision is to macam now kita ada macam NLP dia boleh buat data recognition kan. Pada dokumen nak dokumen tu kita nak fahamkan dokumen tu kan. So kita dah ada data recognition, then kita ada keyword detection and summarization tu kan. So tu dia akan produce macam data as structured data. So macam kalau contoh kita ambil ChatGPT punya GPT-3 dia, then kita ambil yang the structured data yang terdapat daripada entity condition tu semua tu dari dokumen, and then tahu person dia kat situ ada macam Majid something, ada tu ada dia punya organization, ada time apa dalam tu. Dia jadi structured, dan ambil structured tu kita inject ke dalam GPT-3 punya NLP pula. So dia akan macam, adakah dia akan kalau kita tu kita tanya dekat dia jadi macam kita tanya macam about the data yang kita dah tadi tu, kita tanya dekat GPT kita dah fine tune tadi. Kita tanya macam bila event ni berlaku kan. So macam data kita bagi tadi tu dia boleh, rasanya dia boleh tak dapat that information. Sebab kita dah bagi kat dia lah, dekat GPT tu kita dah trainkan data daripada GPT tu. So bila masa kita dengan chatbot dan masa kita tanya sebab data yang kita inject tadi tu, yang kita inject pada structure data tu, so bila kita tanya macam tu dia akan jawab macam dia ada apa dia jawab lah macam tarikh sekian-sekian is event sekian is 3 bulan itu, lepas tu beritahu macam source dia daripada mana gitu. So macam okey kalau nak buat macam tu.
Memang kena buat macam tu. Memang kena buat. Kita punya laboratory system bukan saja dia baca structure data. Banyak laboratory instrument dia buat cloud graph tu. Kita keluar data di cloud graph. Di cloud graph, our system baca graph tu and convert that graph into data. Selalu kita ada data convert graph, ni dia boleh buat balik. Convert graph to data. Okay. Jadi structure data lah. Structure data tu senang, tak payah pakai GPT pun kita boleh learn something from structure data. Basically tu tengok correlation lah, apa benda probability tu semua macam tu lah kan. Faham kan? Betul. Okay. We have to see, memang ada cara lah. Kita kena eksperimen lah macam mana nak combine the AI yang proses structure data ni dengan ChatGPT supaya the output can be from ChatGPT alone.
Sebab dia dah ada capability untuk macam mimic language dengan human language.
Dia macam ni tau dia. Kalau kata kita bagi data pada komputer, lepas tu kita dapat balik data sama, that's not intelligence lah. Okay. Artificial intelligence ni dia bukan macam analitik. Dia ada inference. Inference tu macam tadi predictive tu inference lah contohnya. Dia boleh baca data tu, dia boleh infer something from the data. Dia boleh rumuskan satu pemikiran pada data tu. Okay. Contohnya kata kita bagi data apa semua, orang tu nak bagi hidup ke nak bagi mati. So dia kena infer kat situ, dia kena jawab, dia letak. So that's inference lah basically. Kan? So that is the purpose of AI. Bukan semata-mata bagi data, dia keluar data balik. So kat situ tu dia kena infer. So definitely yang sistem yang buat structured data tadi, dia akan keluar sampai number output. Yang language tu keluar daripada segi bahasa lah. So they have to design a few AI to work together lah in that sense. Kalau pakai LLM untuk proses Aznie such a data is like using aircraft carrier untuk tangkap ikan. Come.
Lama tak jumpa noh. The last time we met dekat tu lah.
Tu lah dekat
Dekat buluh tu.
kedai tu. Ha. Khabar?
Baik. This
So
is
I prepare lah.
this is Dr. Aznie.
Evolve lah. Essentially, AI is the use of knowledge in order to do things macam humans. And the thing is, of course, satu is to predict. To predict lah things. But all the time also is to explain things. So, and that's why bila predictor you use reasoning. So bila you ada knowledge tu, you have to be able to reason, not just macam dia kata lah, you cannot just macam database. Now there are two types of AI essentially. Satu is analytical. Analytical means the other one is empirical. Empirical came later. Analytical means you faham benda and then you represent the knowledge. Basic representation is of course database lah, which is structured data. And then you can also have macam networks, trees or things like that, macam ontologies and all that. And then you can have meta knowledge. So that's representation. And then in analytical there are methods for reasoning lah. Empirical, Jepun yang buat started. Lah. Collect data, whack algorithms. Apa? Whack, bantai. Tembak algorithms. Then they just develop. They developed algorithms. This started in the 70s, 80s. And then one of the first ones was translation. So the algorithm was predicting what is the probability of this being translated to that. Tapi pasal dia ambil patterns. So everything empirical is all about patterns. So there is actually it's not so much any AI, this one is specialized. It depends on the data. Kalau you nak the system to specialize in language, the data is all on language. Kalau you not specialize in images, the data is mainly images. But all the algorithms, including neural nets and all that, it looks for patterns. Essentially, it looks for patterns. So it gets better and better if you feed the data in such a way that it can form patterns. So, which means to say macam the chances are it has a lot of patterns and dia pandai compartmentalize different ni lah. But when it's empirical, explanation is a bit more difficult. Macam at the moment ni ChatGPT punya explanation is more of explaining based on patterns of explanations. Whereas kalau analytical AI, you have to explain it analytically. Why this thing happened, why it happened. So whatever you want to do, first you have to, chances are these days everyone is doing empirical. So you have to know how that particular thing can behave before you know, and what kind of data is being fed into it.
Macam mana kan? Kita nak pakai AI ni untuk buat climate service katakanlah. Yang sekarang ni kita ada 7 days prediction for weather. Okay? So itu dah ada some form of analytical juga, ada data we can give, and then the modeling. Macam mana nak combine benda tu and to have lagi daripada 7 days mungkin sebulan prediction of weather. How? Macam
A lot depends on the data, availability of data.
So the past and real time.
And then the better you can clean the data, the better you can make predictions. But it needs a long year, and the more parameters you have, the better. Because these algorithms, actually you can pick almost anyone. They are all these algorithms all is looking for patterns.
Yang menyebabkan that level of analytical to complex sebab ada banyak climate model pula. Contoh macam kat Malaysia dia ada 5, 9. Kat universiti mungkin pakai 1 je. Tapi you imagine how big the processing
5-9
climate model you nak tengok tu just predict the weather for the next 3-7 days. So yang tu yang
model dia based on some preconceived notion. That
yang ini tak boleh. Kalau you government body, it has to be endorsed. Contoh kita pakai UK punya model ataupun model daripada US.
No, what he's saying is that the model when whoever program the model is this usually the other assumptions.
Of course.
They make certain assumptions.
That's what I do.
And that's how they would program it that way.
Okay, contoh in finance world dia ada model on how liquid is the company going to be for the next few years. Dia ada formula dia. Based on experience dia kata campur tu cash flow ke tengok apa then you know whether the company is liquid or not liquid. So that formula is preconceived notion. What AI does is you take a lot of data and you feed it to the brain without telling it how to process it. The brain will come up with its own pattern.
But
that is AI.
But the thing is, to help that machine, you kena feed it with yang dah ada patterns. Which is why often enough they would normally use some other patterns or some other models, and then tengok data yang help towards the patterns, buang yang outliers.
But that would be bias lah.
Memang.
That would
No,
be bias lah.
how to make good systems, you have to be biased.
So katakan government tak nak pakai, tak buang, kita tak pakai. I publish it on the internet, bagi orang tengok Aznie, nanti orang untuk government.
Yang apa dalam Facebook kan dia ada Majid kan. Kan ada wartawan kan.
But the main thing is to remember is all these systems is that data is king.
Yeah.
Without the data tak jalan. That's why a lot of big data at universities sakit badan. Tak boleh dapat data. Orang tak bagi. Ini pun dia buat ni nak data on traffic, tak ada orang mau bagi. Tak mau jual pun.
I tak tahu pasal berapa lama. 3 tahun tak boleh. Cuma buat tahun segini, 2 tahun segini, tak boleh jual.
Many researchers depend on simulated data.
Okay, itu jadi bias lah.
So simulated data. So those yang can come up with this good system macam is because they have data. Dia orang boleh dapat data tu. Macam Google, dia berlabak data kan. Kalau yang as long as it is there, dia curi lah. Bukan curi lah, dia ambil.
Maknanya kita kena ada exclusive right to the data characters lah. Idea lah.
Doesn't have to be exclusive.
Tak, macam kalau I nak buat lah, maknanya kerajaan yang kena initiate dulu. But the owners is on us. We have to be responsible for that.
Yeah. You find anybody who has the data ambil lah. Tak tahu aviation ada sikit ke, laut ada sikit ke.
Easy lah.
Betul lah, orang tak nak bagi. Itu masalah.
Memang orang takkan bagi punya. Unless because you work in the government, so therefore you somehow use the government punya ni. University tak boleh. University tak boleh. University has no ni. But data, without data,
tak boleh train lah memang. He start with a blank brain. And we don't teach him how to think. Kita bagi data, he thinks how to think.
Tapi yang cantik ni, even because dulu one of the main criticisms of empirical AI, dia orang tak boleh explain. Can never explain kalau tak jalan, tak boleh explain. Tapi now, especially good example is the ChatGPT tu. What they do is they put in data on explanations. Kalau ada problem ni, macam mana explain? Ada problem ni macam mana? So therefore, the machine can dig up macam mana nak
Mana
explain.
dapat dia tahu mana dia dapat.
Yeah.
So they have to feed data on how to explain. No, but clarity is important.
Ya. Kita guna benda tu mesti kita guna bijak juga.
Ya, betul.
You have to know
Kita guna
exactly.
bijak juga.
The main thing is you have to know, especially PhD, you have to know exactly what will your research contribution be.
Itu tak ada masalah. I risau sekarang
Bukan tak ada masalah.
Tak, otak tu dah mula nampak anak study ni ke mana.
Oh, you mean you tak sampai lagi to that stage?
Yeah.
Because at one stage you have to be able to say, okay, this is my added value to this whole thing. You see, especially bila buat empirical ni, kalau computer science sakit lah, because you need to show that you are adding value to the algorithm or to the design of the data or the kalau computer science.
Kalau buat modeling kan.
So that means the application orang tak kisah. Or the feeding data tak kisah. So but in other domains not so bad lah, because they can show contribution, different ways of showing it. But the main thing is I call it delta R. Delta research, delta knowledge. What is it?
The difference saya ingat kan.
In fact, I ngajar research methodology. I've done almost 1,000 thesis. Supervised.
Kalau tahu tadi baik kita buat laptop.
But the main thing is that there is a table which the table of problem, research question, research objective, and then research contributions and deliverables. So you do that table, and then when you write the thesis, you must follow.
Kita tu juga lah. Besok nak itu.
It all depends on domain tu you nak buat apa. Kalau silap, macam dia ni, dulu dia buat network modeling, supervisor entah apa, OI. Tak kena.
Tapi okay, so
Actual sign.
yang ini I kena buat lagi sekali dia proposal. Sebabnya the initial tu terlalu besar.
So lah dia komen anda email.
Boleh.
Untuk esok kan, cepat.
Tak apa, besok tu interview.
Your initial yang pasal suka sungai kan? No, pasal tak pasal sungai.
Sungai tu using ChatGPT I've identified what kind of data and also the availability that I need to provide. So I tengok besok, oh ni tak ada masalah sekarang ni aku boleh.
So, why do you have to modify?
Dia kena
Sebab-
tengok.
Tak ada masalah.
Sebabnya dia kalau kita punya ni dah mix dia ada quantitative dan qualitative. Jadi the issue ni is still the data.
Data tak available.
I fikir macam ni dia, siapa buat study tu I pakai dia study dia jadi secondary. I fikir lah macam tu.
Boleh lah dapat PhD, just do secondary study.
Tak boleh, I punya
Boleh,
data
depends on how
collection.
you formulate.
Yeah, I punya collection would be verifying apa ni semua. I kena buat interview juga. Tak payah start dari mula. Kalau tak kena follow.
Ni banyak sangat dia. Too many things in that.
Yeah.
In that paragraph, too many things. But first is the input, and then you have.
Ni.
I'm saying there are too many things.
To study.
Huh.
Dia objektif
And
dia
then,
terlalu besar.
and then because you masukkan apa ni adjustments, you masukkan policies.
Yeah.
the main thrust tu tak nampak.
Ya. Macam contoh daripada sini ada climate side, ada the social economic side, so it's very too big.
So what should be done about that?
Kena narrow down.
Itu yang I apa?
You have to narrow down one aspect saja dulu. And then you buat betul-betul that one, and then what if you tambah, what if you add another parameter.
Then baru you macam a tree lah, you grow.
Start
So
small first.
macam the first basic things would be the climate, would be the environment, would be whatever, more physical lah kan. And then you buat the predictions and whatever. And barulah you adjust later, because later you ada cakap tu ada policies lah, ada apa.
Apa nak buat interview tu?
Kena cakap je lah, kena buat macam buat diagram lah, you fikir dalam diagram ni ada additional factors.
I nak lagi luas je. Tak payah tanya orang lain lah.
I ada toko kat rumah. Tahu, I enroll my PhD 3 tahun I duduk Lelong. I balik, dia tengok I duduk pening cakap dengan dia. Dia cakap 5 minit je I bilang.
Oh iya ke?
Cakap supervisor I tak cakap macam tu. I lost bila ni nak buat PhD kan. Bocor ni you tak tahu kat mana ni nak ni. Tadi dia cakap sekejap. Buangnya I punya network diagram kat depan tu dia dah. Cannot see. Dia tak boleh nak relate the model dengan the real situation. I put it in notes and link semua kan dengan app semua, dia dah tak boleh. Macam dia dah panik. I kata this is how Toll Plaza look like after I put it in a network. So I
Dia tak nanti baca diagram
dia
tu.
tak nanti baca. Dia tak nampak sampai sudah.
Yang you kata network tu ni lah berkait dengan highway.
I buat congestion.
Oh,
I set congestion.
Air.
Congested.
Air boleh.
Air pun ada connection juga.
Air.
Sama, air juga.
Air traffic. Liquid. Anything that
Dia
flow.
punya
Boleh.
PhD boleh apply to air.
Anything that flow.
Anything that
And
flow.
then- and
Tapi
everything
air pun ada
you
turbos
need-
kan.
That yang kena tunggu.
Dam.
Queuing theory.
Kalau macam tu,
apa
kenapa
dia
nanti?
tak faham.
Palingnya, sekali kita buat
Nak
modeling
explain.
apa boleh lah.
You see, but her contribution is the design of the network. You see, this is why the R&D macam your case, you have to cari apa dia yang the main contribution. Macam hers is the model of the network. The network, how to design the network.
Ya,
Bukan dia algorithm, bukan dia apa, algorithm ada lah, but it's not the main thing.
And then I study kat mana dia congestion. From one unit ni, link to this one, apa jadi if you increase flow sini.
Sama lah macam,
So
see,
you predict, you
when-
nampak congestion is coming, then you have to make decision.
when you have air flowing here, and then maybe ada dam ke ada some ni, and then
Outlet then.
there will be a jam. Kalau lah there's more water coming from another river, another stream kan, then there will be a congestion bila banyak nak masuk tol. So that kind of thing lah.
Yang my research is going to be this. Okay, katakanlah dekat satu kan dekat river basin yang Klang tu tadi, you dah invest banyak ni untuk flood mitigation, you dah buat banyak ni untuk sea level rise kan. So apa by 2100 yang kata kita punya increase in temperature tu naik, lagi banyak flood tu tak. Sekarang kerajaan nak letak kat mana intervention? And then how to
prediction.
and then
kat mana yang dia akan jadi overflow apa tu,
itu
congestion lah.
Congestion lah.
Because dia banyak.
Not only that, tapi even opening of new township, macam puncak alam, setiap alam semua tu pun
dia akan
ada impact.
And also macam the one you kata the temperature naik kan, which will increase the so those are
You know,
factors.
my study, I ambil Taman Sara tu Plaza kan. Taman Sara kan dekat situ kan satu sekarang tu Plaza mana pun jam. my conclusion is get rid of all the 2 plaza.
Senang.
If you want to have a 2 plaza, it has to be keluar daripada city. Dan dia punya queuing area dia has to be how many kilometers for how congestion dia, banyak mana cars can wait there and come out. And come out tak boleh ada link lain masuk join after how many kilometers.
Switzerland has no jam. You know why? Dia ada highways. Senang je. You want to use the highway, you have to have a sticker. You pay annual sticker.
That's what I want to propose.
The annual sticker you beli, then you can use it anywhere. So you beli buyer lah. So and the thing with your apa tu? Kalau you guna highway without a sticker, you know what your denda is? You buy the sticker. On the spot. Yes.
Lepas tu, okay, tu tadi yang intervention tu engineer ni. Maknanya dia tahu hydrology. Sebab kita cerita pasal river, tapi saya polisi, saya nak tahu apa untuk lagi 100 tahun kita ni, intervention tu apa dia punya, kita punya option.
Actually, exactly the same as her here, because
Jangan boleh pakai modelling katakanlah
because with that it is to predict when you predict that there will be a congestion, there will be a congestion macam air tu, and that's when you bring in the solution. Macam your case, the solution would be from hydrologists. Macam her case, the solutions would be more on like tukar apa ni, plan for detour routes and things like that. So kena separate. Satu is to recognize the potential problems. Separately would be the list of potential solutions. So hydrologists shouldn't come in
the solution.
It comes in only at the solution. It's a solution level. But the application is not not necessarily to mitigate. Solution is to prevent. Maknanya the hydrologist says, if this is the problem,
the prevention.
The prevention. Why don't we just start building the?
Itulah penyelesaian dia. Sebab tanya lagi satu, kan? Ataupun I don't know, some development buat wetlands. I don't know, maybe it's too.
I think you have to come up with a list of possible solutionists, not just hydrologists. The town planning also, macam mana nak bubuh towns and all this. So those are a list of possible solutions given.
You understand the problem?
Memang kompleks memang ni.
It is, but all the more reason you have to compartmentalize.
Dulu kita buat bandar, katakanlah
Town planning kita tak tahu.
Town planning kita ni,
kita tahu.
kita tak payah fikir pasal climate change. Dulu kita fikir orang nak duduk mana, nak pergi kerja kat mana.
Mereka dulu main dalam bubuh je. Sekarang ni I tengok hospital. Because I was admitted to Sedang Hospital kan. That's supposed to be
That's the clean
heart ni kan. And then I said when they build a hospital, do they study the surrounding dia, how the density of the population there, what are the age range. Kalau lagi tua kan chances of getting penyakit dia banyak kan. So the access to the hospital is a network. Ada variable dia yang a hindrance to us to move towards our goal. Kan? So these are the constraints lah.
Yes, but I foresee one problem that you will have. You see, a lot of input, quite easy to see macam water flow, size of rivers, senang. And climate, senang. Tapi one difficulty you will have is how will climate change affect.
Memang susah sebab
Susah nak explain how a change. Kalau lah climate, kalau
okey, kalau macam tu jawapan dia ada 3 benda je. Okey. Sorry, 2. the driver for climate change are only two things. One is water. Maknanya hujan banyak ataupun sikit. Nombor dua adalah kenaikan suhu. Panas ke tak panas. Itu je. Tapi sebab you cakap nak ambil input dia tu, I tahulah kat mana nak dapat data tu. Tapi bila nak keluarkan the aspect of climate change at
Okay. So you have the source of climate change, and then you have to tie to what effect it will have on the. Then you have to tie the impact on this standard flow. Katakan if there is no climate change, there should be a standard flow. Once you make a change, it can be any change. You put a town, there is a change. You put something else, there is a change. Now climate.
Simulation also.
Saya nak study satu je. I tahu kalau cerita semua memang banyak, tapi I pilih flat je. I akan pilih flat je. Sebab flat mitigation pun ada banyak macam-macam.
Tak. The way you present, you should present that there is a basic model. There is a basic way of things happening, and then things will change when you start adding. And then you show, first of all, main thing is establish the basic thing, the basic flow, the basic things that are there. And then once you start adding things, then you can talk about what effects. So one of them is the climate change. It can be structural changes, for example, a new township. It can be so those are changes, but you must not. The basic ni you kena tunjuk macam dia punya lah.
Compare lah before.
The model, the network of traffic. You want to show the network of the waterway. This is how to model the network. I think it's very similar to us. Macam tu, without touching. And then bila you start adding things, then you will notice other.
But I would think rather than flood ni pun memang disastrous. But I think more than flood is access to safe water. You have water but it's polluted. Then the shortage of water.
Kita share artikel dalam LinkedIn tu kan.
I think flooding is easier.
Easier. But I think that is more pressing. There may come a time when we won't have enough water to drink anymore. And because then the groundwater, then the ground will sink.
No, not necessarily. Groundwater gets recharged.
Kena tengok juga.
There are also two parts to this. Satu is the source of non-contaminated water. How to make. After that is the flow of clean
potable water.
Potable water. So these are two
different things,
and they flow differently. And the contamination can come in a very different way.
Kali kita kena ada ni lah whiteboard.
Macam after dia clean tu, dia Cina berak.
Research assistant ni semua.
Kita
Even food security lah. Ini opportunity ni. Soil punya pemeliharaan soil tu sendiri, which will be affected by dry air, So don't think about technology for technology's sake. You have to solve real issues.
Itu cara isu yang kita nak solve ni.
Yalah.
When kita ada knowledge, kita ada.
So when El Nino comes here, the air is going to be dry.
Sebab air sudah sebab dia increase in temperature tu tadi.
So air tu pergi ke mana? Because El Nino got to come from America je kan?
Bukan. Dia macam ni kita ni ada apa? Kita ada climate system. Climate system ni dia bolak dari atas, bawah. So yang mengcool, absorb laut, water bodies. Lepas tu dia condense air itu naik ke atas. And then dia turun balik ikut hujan. Macam itulah cycle-nya. Hydrology cycle, climate system, everything is like that. Like that. So bila El Nino, angin tu tadi dia datang,
dia ambil tempat lain.
Bukan ambil pergi tempat lain. The air becomes dry because that's how the earth stabilize the temperature.
Okay, this is my question. How does the air become dry in Malaysia, which is surrounded by sea on all sides. So no matter where the air is coming from, east
Okay.
to west, it will come
Another,
through the
there's
ocean.
another explanation for that. Have you ever heard of the Indian Ocean Dipole? Indian Ocean Dipole. Saya ni, kalau musim kemarau yang begitu teruk kat Australia, dekat Afrika dia banjir. Itulah dia punya perulakan peralihan
Okay,
angin.
itu maksudnya
peralihan tu semua.
angin tu bertiup ke arah Afrika lah.
Dia
tak,
akan berulang.
dia nak buat in specific terms, kenapa jadi macam tu? Pasal angin yang
I
seperti
nak
bawa air
explain,
pergi ke
I Google, I bagi kat you.
okay,
What is
that
El
is a
Nino?
solution that
Yeah.
some aliens taught my friend and my friend taught me. Alien tu.
Warming of the ocean
Alien mana
surface.
tu?
Yalah, warming lah, tapi but how does it translate into dry air to us?
Macam sekarang lah musim hujan yang angin bawa kan.
Yeah.
Now we are feeling like cold, dia orang kata ada snow dekat.
Yeah, it's a wind direction lah, coming from where apa semua tu
It's
lah.
from the north or south pole.
Yeah.
Okay, yang tu I understand. Okay, let's understand what I understand first. What I understand is okay, ocean warming semua tu, and then belah South America, belah Philippines. Lepas tu angin tu either tiup belah sana, tiup belah sini, tiup from China, tiup apa semua tu. Yang tu I understand.
Tapi
And
kenapa
Indonesia
Malaysia
semua.
affected?
Tapi kenapa Malaysia boleh ada angin kering?
Bukan angin tu kering kan? Ini temperature naik.
Ya, temperature naik, angin tu tetap tak kering kan? Tetap ada humidity kan?
But
Okay,
this-
then I have this solution yang some aliens taught my friend and my friend taught me.
Ni alien dekat gunung luar pun mana?
Tak ada, alien dekat ni. Dekat California. Okay, apa dia ajar? Dia ajar, dia kata you got to grow mushrooms.
Macam business mushroom lah.
Tak. Dia memang asal-asal tu kan. Dia 15 years ago. Dia ajar, dia kata you got to grow mushroom. Lepas tu mushroom tu release spores. Lepas tu spore tu naik atas ke langit. Water will coagulate around the spores, forming raindrops, and then fall back to earth. And the proof, when he told me that the aliens, I asked him, he's an 80-year-old man. Dia tu macam blur-blur sikit lah, dia dah tua sangat dah.
Tapi awak cakap ni kan untuk satu negara, contoh macam ni lah, Negeri Sembilan lebih kering daripada Kuala Lumpur.
They grow a lot of mushroom kat Negeri Sembilan lah. So that the spores go up Negeri Sembilan.
To fight, mungkin microclimate lah dia punya penyelesaian dia. Kita punya pokok.
Ya, mushroom tu spores tu
Ya.
akan bawa turun.
You will have a major danger.
Pasal? Kenapa tu?
You may be doing your literature survey for 3 years. That's one thing I always discourage a lot of students.
Okay, evidence dia, where is the region yang ada highest rainfall on earth?
Typing.
Kan?
Tapi is wet.
Bukit Maxwell.
Amazon basin. That has the highest rainfall
Dia cakap
on earth. Okay. In the Amazon basin, every year, the mushrooms there release 64 million tons of spores into the atmosphere.
Itu spores tu menunjukkan cuaca.
Spores tu naik atas, coagulate jadi hujan, turun balik. Yang ni dah ada research semua dah. So after he told me that, the alien told him, then I did my research and I found that it's true.
Ya.
And then dia cakap lagi tau, some other facts. Dia kata apa? Dia kata mula-mula dulu tak ada binatang boleh hidup di atas darat, tak ada tumbuhan di atas darat.
Sekali
Dia
bila
kata
ada
mula-mula
mushroom,
sekali, mula-mula
dia
sekali
bukan mushroom hisap mushroom
kan.
That's true.
Jadi alien datang dan alien tanam mushroom dulu, fungi dekat atas tanah.
Itu jangan berbual dalam fisis.
Lepas tu bila mushroom dah tumbuh atas tanah, barulah binatang lain boleh hidup atas tu. Then when I did my research, sebenarnya asal-asal those small animals dengan single cell animals tu from the sea cannot grow up on land pasal banyak bakteria.
Jadi mushroom makan.
Tak, bila ada fungi, Alexander Fleming tu, yang penicillin tu, fungi tu kan dia bunuh
Bakteria.
bakteria. Then barulah benda-benda hidup. And then I did more research. The fungi industry is worth 40 billion US per year untuk keluarkan antibiotics.
Jadi fikir. Tapi berbalik kepada tadi. Katakanlah macam mana nak selesai? Dulu, zaman dulu kan kita ada musim kemarau kan. Kita tak ada risau sebab we don't know, Masa tu kita tak tahu.
What you don't know what to do.
Yes. So somebody will die during the kemarau and let them die.
Dulu masa zaman kita dulu, the earth had only about 20 billion people. Sekarang ni dah not 20 billion, 4 billion people. Sekarang dah 8 billion people.
9 kan.
Coming to 9 very soon in 1 decade.
Yeah.
My time was
So we
only
have
2.6.
we don't have a buffer anymore.
Tapi awak cakap tadi masalah air tu betul. Air tu memang ada. Another one is food. Food security, Kalau tak ada
Habis lah, banyak belum nanti.
There is a company somewhere in Subang Jaya. Ada our student buat research kat situ. They generate water from air. Dia punya machine takes water.
Okay, back to that question just now. Is the air humid or not? Yang tadi El Nino
Sebab
tadi
kita
tu.
ada humidity. That's why dia
Kalau
ada
El
air.
Nino tu kalau tak ada hujan disebabkan air tu kering, El Nino tu bagi air kering dan tak ada layak.
Dia bukan
So kamu kan tak boleh buat lah.
kita rasa panas tu sebab the ocean tu warming kan.
Okey, tapi dia tak turun hujan tu kenapa? Pasal dia pergi tempat lain ke apa ke?
Banyak bomo.
Tak
Bomo je.
tak bila kenaikan suhu dia akan akan
Kenaikan suhu air tu naik. Lagi hujan lagi
evaporate.
evaporate tak ada.
You need
Unless air
Atau dan it's getting more humid to match the warming tu, like dia lebih teruk, but we don't know when.
Okay,
Kan ada cycle
we got to
kan,
find out
tahun
tu. Tapi kalau katakan
banjir.
humidity is there, then we have to do something lah, extract water from the air apa semua lah kan.
Kamu tak lewat.
Mekah dah hijau dah.
Pokok dah pokok dah naik. Aduh tunjuk kat dunia.
Tu dah kita memang dah kiamat.
Bila sana hujan.
So dia orang boleh buat.
Ada dekat kiamat yang orang kata because it's
Oh dah banjir dah. Bukan.
Abdullah punya rumah
Dia
dekat
can be a
sebelah.
real serious problem. Kita 24